Hello, how are you? Welcome to a new video from the AbadIA and its most agentic version. Today we are going to talk about Google's A2A protocol and how communication between agents is essential for multi-agent systems and how this protocol becomes a vital piece that will help us a lot in this project. But I won't keep you any longer. Let's get started. AI agents, especially those powered by LLMs, are kind of stuck with just their training data. To actually interact with the real world, or, a game world, they need to grab external info and actually do stuff with it. The Model Context Protocol, MCP, gives agents that standardized way to hook up to these external resources, including the AbadIA game API. What is MCP? The Model Context Protocol, MCP, is an open protocol that standardizes how AI applications clients give context to LLMs, and interact with outside tools, systems, and data sources. Its whole purpose is to let agents grab real-time or specific data whenever they need it, without needing custom code or proprietary hookups. It solves that annoying information silos problem by giving everyone a universal way to talk. The core of MCP works like a client-server relationship. MCP host. This is the AI agent or application, like Claude Desktop or your IDEs, that kicks off requests for outside resources. MCP client. This little guy lives inside the host application, mediates communication, and turns AI intentions into MCP requests. MCP server. These are lightweight programs that offer specific abilities, tools, resources, prompts, to AI agents connecting to local data or outside services. Key parts of MCP include tools. These are executable functions, like asking a database, generating a file, or using APIs that agents can call. Resources. Think of these as structured data, files, database entries, API payloads that the server can access. Prompts. Reusable templates that show agents how to use tools and resources. Communication within MCP uses JSON-RPC over standard I/O, SDDO, or HTTP/server-sent events, SSE. The cool things about MCP are that tools can be combined. You can trace decisions. It allows cross-functional orchestration. It's adaptable, secure, and helps with regulations. In the world of MCP, the roles and functions of its components are like this. The MCP host is the app or AI agent that starts a request to get to external tools or data, acting as the starting gun for the interaction. In the AbadIA project, this could be the planning agent that decides it needs to move the character or check out an object in the game. The MCP client lives inside the MCP host and acts as a connector, turning the agent's intentions into MCP requests and sending them off to the right server. For AbadIA, this would be the module inside the action agent that turns an order like move north into a standardized request for the game server. The MCP server is a lightweight program that offers specific capabilities, tools, resources, prompts to AI agents. It hooks up to local data sources or remote services and does the requested tasks. In the AbadIA project, this would look like the AbadIA game API server, which offers functions like move_character, direction, or examine_object, name, as tools, and the current game state as resources. MCP servers let agents get to tools and data like this. An agent, the host, sends a request through an MCP client to an MCP server. This server then talks to the external system, like the game API, and sends back the result. For AbadIA, we'd build an MCP server to expose the AbadIA Delcrimen game API. This server would turn game actions, e.g., move north, pick up key into MCP tools, and game state queries into MCP resources. This would let AbadIA agents see the game world, move the character, and interact with game elements, effectively connecting AI smarts with game mechanics. Examples like the Playwright MCP for testing web applications or database MCPs show how AbadIA could talk to its game state or API. The MCP is the super important piece that lets LLM-powered agents go beyond just writing text about the game to actually playing it. Without the MCP, agents would be trapped by their training data, unable to mess with or even see the changing game state. This is absolutely fundamental to our project's goal of solving the game. When building the MCP server for AbadIA, security stuff is paramount, even in a game. This means protecting the game API and stopping any accidental bad actions. All those mentions of security, data privacy, authentication, compliance, and human-in-the-loop permissioning models in MCP descriptions just underscore that hooking up AI to external systems isn't just about making things work, but also about tight control and security. This really shows that building real-world AI agents needs careful attention to security and control, not just AI smarts.